Here is your introduction to 5-1. There's quite a bit of information that I want to share with you before we actually start the examples, so that is where we're going to start here. First of all, everything in this lesson is going to be about a pair of parallel lines like this with what we call a transversal. So the two blue lines are the parallel lines, and of course the red line is the transversal. Now when we talk about angles within all of these different angles here, we're going to talk about different areas of the parallel lines. So first of all, we're going to say that this is exterior up here, and it is also exterior down here. And what that means is that's all of this area down here, these angles, and all of these angles up here are exterior. Then in addition to that, we have interior angles. So the interior refers to inside of the two parallel lines, and exterior refers to outside of. So these are our interior lines. And what I want to show you is that we have some specific angles in regard to that. So let's talk about these angles here, for example. We've got this angle here and this angle here are related. And when we talk about the word alternate, we mean that they're on opposite sides of the line. Opposite sides of the transversal, I should say. So when we look at these two angles right here, they are alternate and they are interior. And those are the two circles there. Then additionally, we have these two angles. So the two x's are also alternate interior, and I'm going to abbreviate that in this case. So those are alternate interior. Then we also have a pair of angles up here. We've got this angle here and this angle here. So we have the x's here. Again, they're on alternating sides, so they're alternate. But in this case, those are both outside of the parallel line, so they're alternate exterior. And then lastly, we have one more set here and here. And those are right here. Those are also alternate sides, and they are exterior. The first part of what you need to know in regard to this lesson is you need to be able to spot those. And we do that basically by the two words, alternate, paired with either interior or exterior. Exterior, remember, is this area up here and down here, and then interior is this area in here. Now there's one more thing I need to show you. So if we go back to our parallel lines with a single transversal crossing through them, now we're going to end up with a different type here. We'll start, these are going to be what we call corresponding angles. These are called corresponding because they correspond. So it's this position here and this position here. Notice they are both to the right, they are not on alternating sides, and they are both above the parallel line. They're not interior, they're not, one is an exterior, one is an interior, and they're both on the right. That is the way that you should see this position. So these are corresponding in this case. So we have another set of corresponding angles here and here. And we have another set of corresponding angles here and here. And our last set of corresponding angles are here and here. In each of those cases, those are corresponding angles. First thing you need to do is put all of that into your notes. I have a couple more things that we want to put in the notes here as well. So let's pretend we have some intersecting lines here. We will talk about this. These two are vertical angles, and these two are vertical angles as well. So basically what a vertical angle is one angle directly across from another. Here is another set of angles that I want you to understand. We could have angle A and angle B. We would say that they are supplementary. This is not in your book, so definitely put this in your notes. They equal 180 degrees. So if we had angle A here, this angle here is 120 degrees, we would say that angle B is 180 minus 120, or 60 degrees. So angle A and angle B have to add up to 180, therefore if we know that this is 120, angle B must indeed be 60. Lastly, if we had this situation here and it was marked with the red symbol like this, these would be complementary, and that means they equal 90 degrees. So if we had one more here like this, so if we had 40 degrees here, this here, if this is angle A and this is angle B, we could say that B is, now this is a 40 here, B is 90 minus 40, which would equal 50 degrees. And that would make them complementary angles. They add up to 90 degrees. And please make sure all of this is in your notes before you begin today's lesson. Okay, so that has been some review, and now you can start looking at some of this. And basically this right here are the things that we just talked about. We talked about a transversal. That would be this line right here is the transversal. We talked about interior angles. That would be 3 and 4, 3, 4, 5, and 6. All of these angles are interior. We would have exterior angles of 1 and 2 and 8 and 7, just like it says here. And then we would talk about alternate interior angles, for example 4 and 6. So let's back this up a little bit. So we'll use this color here. 4 and 6 would be 4 and 6. That would be alternate interior, and so would 3 and 5. And we also have alternate exterior, so 1 and 7. 1 and 7 are alternate exterior, and 2 and 8 are alternate exterior. Make sure you have this in your notes because this is quite a lot to remember. And then lastly, we have corresponding angles would be 1 and 5, for example. 2 and 6, I'm not going to mark all these. 4 and 8, so we could mark 2 and 6, for example, but it's going to really get crowded here with the same color ink, and that's why I did it on the other page in various colors of ink. Another thing I want to talk about is this piece right here. Special notation for perpendicular and parallel lines. This is how we write perpendicular lines, and what perpendicular means is that they meet at a 90-degree angle, and that's what this red symbol here is for, to show they're at 90-degree angles. So we would say that line M is perpendicular to line N in this way here. Okay, and lastly, if we're going to show parallel lines, you can show parallel either by saying P is parallel using this symbol here to Q, or you can just do it right on the lines by putting these two symbols here. So again, you can use this symbol for perpendicular, these symbols for parallel. You can use this to stipulate line M perpendicular to N, and you can use this to show that line P is parallel to line Q. And now things are going to move much more quickly now that you have that background information. So let's take a look at number 1. Number 1, they say classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. So we have 1 and 7. So here's our two angles here, 1 and 7. You can see that they are on the outside of the parallel lines, in other words, exterior. And you can see that they're on opposite signs, or in other words, alternate. So your answer is alternate exterior angles. Problem number 2, we're looking for angles 2 and 6. In this case, you could see that they're both on the right of the transversal, and they're both above their parallel lines, and that makes them corresponding angles. Just that simple. Please press pause and do letter A. So now let's take a look at how we could use that information in order to do something with it. And in this case, what we're going to do is we're going to find the missing angle measurements. When two parallel lines are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measure of all of the angles. Suppose you know that the measure of angle 1 is 50 degrees. Now when you do these in the book, the very first thing I want you to do is write a 50 right in there, so you immediately know that that angle is 50. You can use that to find the measure of angles 2, 3, and 4. Because the measure of angle 2, let's switch our colors here, which would be this angle here, would be 130 degrees, because we could take the 180 minus the 50 there in blue, minus 50, and that would give us our angle of 130 degrees. So we know that this is 130 because those are supplementary angles because of this straight angle here. Then the measure of angle 4 equals 130 because angle 1 and angle 4 are supplementary as well. Or you could recognize that these would be vertical angles here, so that makes this 130, and then we would also have 50 right here for angle 3 because it's vertical. Or we could look, because there we go, right here, vertical angles. So you can see that once you know something about a particular angle with two parallel lines and a transversal, you can calculate quite a lot from that. So let's take a look at a sample problem here. Problem number 3. We have a furniture designer built the bookcase shown. Line A is parallel to B, so we have these two lines are parallel. This one here and this one here. We have the measure of angle 2 is 105 degrees, so again right away I would write that in here as 105 degrees. And we need to find the measure of angle 6 and the measure of angle 3. So the two we're going to look for are 6 and 3. So the first thing you can do is recognize that the 105 and 6 have to add up to 180, so we could go 180 minus 105, and we get angle 6, which is going to be 75 degrees. That math is here as well. So now we can mark that here. This is 75 degrees for angle 6. And now we can see that angle 6 and 3 are alternate interior, and because they're alternate interior, I haven't really made a big deal about this yet, but all of these alternate interior, alternate exterior, corresponding, vertical, all that, those are all angles whose measures are the same. So we can show that the measure of angle 3 is also 75 degrees because it is congruent to the measure of angle 6. Please press pause and do letter B. Problem number 4. In the figure, line M is parallel to line N. So these two lines are parallel to each other. Line Q is perpendicular to P. So these two are perpendicular, and right here is the easiest way to notice that because we have our right angle there. And it says, what is the measure of angle 7? So let's back this out. This right here is what we're looking for. So we'll put a question mark there. We have measure of angle 7. The measure of angle 1 is 40 degrees. So let's mark this right away as 40 degrees. So now we can take a look at this. There's several ways that we can go about this. We're looking for the measure of angle 7. So measure of angle 7, well, right here we can figure out the measure of angle 6 as being 40 degrees because 1 and 6 are alternate exterior. So we can immediately say that that is 40 degrees. Once we know that this is 40 degrees here, we also know that this is 90 degrees. Let me trace this in red here so you see this. This right here is 90 degrees. So we would have 90 degrees plus 40 degrees right here plus an unknown has to equal 180 degrees. So in other words, we could add the 90 and the 40 would be 130 plus x, we'll call it, equals 180 degrees. We have to subtract 130 from both sides, and we get that x equals 50 degrees. Now, I did my math just a little bit differently than they did it here, but you can see here that basically it's the same thing. So I'm going to refresh. We need this angle here. We gathered that angle 6 is 40 degrees, and that angle plus this 90 degrees here has to equal this 180 degrees of this straight line. So this is our 50 degrees. So 40 plus 50 plus 90 equals 180, and it checks out.